Hello, and how are you today? Today we are going to work on our yoga positions. No, hell fuck, no. No, yoga's fun, but whatever. So, I decided that this was really nice for the back, you know? Not that I was doing anything strange or kinky or weird. But anyway, many of you guys there's a misconception about battery voltages. So I wanted to clear that up. First of all, let's take a look here. I'm gonna include these images, but so here's some battery swing voltages. Now this isn't entirely accurate, but it's pretty much there as far as AGM or SLA or flooded lead acid batteries go, okay? So when somebody says 12 volts, it doesn't literally mean 12.0 volts on the dot. In fact, that's very inaccurate. Just like if somebody says 24 volts, they don't mean 24.0 volts on the dot. And with 48 volts, it's not 48.0 volts on the dot, especially with telecom. If we're talking about lab setting electronics, like internals for logic systems in motherboards and CMOS boards and whatnot, usually internally you'll see 1.3, 1.5, 3, 2.7, 5 volts on the data buses. And those are spot on, they really should be. Inside of a computer there's variances as well, but when we're talking outside plant or anything that involves UPSs or DC power where typically you would assume that there would be backup power, it's a general statement. So with 12 volts, the swing voltage is typically from 10.5 being a dead battery, like really not good for it, flat, to 14.2. Okay, so 14.2 is full charge duty, right? So once you hit 10.5, it's depleted. When you hit 14.2, that's usually an automotive RV deep cycle. That means that it's actually like really charged. It's, you know, it's running at an idle state because the idea is that with an alternator in a vehicle, it'll push up to 14.2 to charge the battery much faster, okay? Now, when we're talking about duty in a fixed position plant, like a UPS or a DC plant, again, I'm just using 12 volts as an example, 13.5 is your float voltage. You won't get any higher than that, and that's because we're using sealed lead acid batteries, otherwise known as absorbed glass mat batteries. You can't replenish the water in them, and they're not designed to be replenished. So you don't want to charge them up to 14.2, even though it says on the side of the cell that they'll take 14.2. If you do that constantly, you're gonna boil the water out of them. So you'll actually push all the moisture out and it'll vent through the vent caps, and eventually the batteries will suck in the sides and they'll be fucked. It's two things you don't want to see. It's a battery going or a battery going. Both are bad. So anyway, let me digress. 12 volts is the base model I like to use because most cells that we use in our systems are based on 12 volts. 12, 24, 48. So see, 12 times 2 is 24, 24 times 2 is 48. So you see where you can get the base common denominator because most of our idiot monkey brains understand the 12 volt swing cycle, right? 10.5 dead, 13.5 float. So now let's translate that into a 24 volt plant. So a 24 volt plant would be dead at 21 volts, like dead, and it'd be fully charged at float at 27 volts. So when we say 24, we mean anywhere between 21 and 27 volts, okay? And remember, as the voltage depletes, the wattage is a constant, so the current will increase as it gets lower and lower. So we want to try to keep it in between the 21 to 27, right? Hence 24 being the nominal median, right? Let's go to 48 volts now. 48 is pretty easy too. 44 is fucked. Dead fucking flat. Done. Dead. Right? 54.4 is float, okay? And that's, if you look at the numbers here, so it goes 13.5, 27, 54.4. Those are the float states. When you've got DC plants of any kind, whether it's a cottage off-grid system, whether it's a big telecom or radio transmitter system, or whether it's standby power for a UPS, or for computers, or standby for a DC plant, for like a cable plant or a fiber plant or whatever. It's going to be, say, 24 or 48. In most big telecom, it's 48 volts. So 48 volts means that it floats at 54.4. And by the way, there's higher voltages too. So when we are equalizing our cells, because realistically, I could go down the fucking rabbit hole for days about battery maintenance, but we can actually equalize them high. We can hit 57 in some cases to balance the cells, which will bring the cells to a closer balance. Because when you've got a chain of 4 batteries, The ones on the outside seem to get more exercise than the ones on the inside. It's just naturally how it flows, right? So eventually, the cells in the center will become lazy and they'll be lower, while the outside cells will be higher. And if those outside cells lead while the inside cells tail, what can happen is that you can go full charge, and these ones will be at 54.4, and these guys might be at actually 52. And then you'll get that state when they get out of balance. The easy way to fix that is take all your batteries out. Usually you'll have two chains, right? So you have 48, 48, and then they'll be paired together, right? So you can take one chain out, remove all the jumpers, and connect all the batteries' positives together and all of their negatives together and make one big 12-volt battery. You leave it like that for 24 hours and it will do what's called a balancing, which is where all the batteries will reach a similar state. They'll all be at the exact same voltage after 24 hours, and you can put them back in chain, and now they'll work together again. They'll be back into a proper state of charge. So there you go. In summary, when somebody says 12 volts, they're actually saying 10.5 to 13.5 volts, okay? When they say 24 volts, they mean 21 to 27. And when they say 48 volts, they mean 44 to 54.4. And remember, you can go higher on flooded cells. So as an example, in a 12 volt system, the high for flooded is 15. In a 24 volt system, the high for flooded is 30. And in a 48 volt system, the high for flooded is 60, okay? And when they reach those voltages, they do what's called equalize, as I was touching on earlier. And you only do equalizes really on a flooded system because they have a reservoir in the top of the cells that allow you to replenish the water that's in the batteries. So with flooded cells, they're designed to take a fucking beating. They are more resilient and tough than a sealed lead acid battery. That's why in much larger systems like cottages or a commercial off-grid, we typically go with we call them like this: golf cart battery, scrubber battery, forklift cell. Forklifts are 2 volt cells. But the idea is that they have a lot of water in them. So anyway, there you go. There's a breakdown of battery voltages. Again, 12 volts means 10.5 to 13.5. 24 volts means 21 to 27. And 48 means 44 to 54.4. So when you see a piece of technology that says that it's 48 volts, no, we don't mean 48.0 volts dead on. There's actually a bit of room to move between them, okay? It's not literal. It's generalized based on the swing voltage, the swing charge states of these batteries that we typically use in telecom plants. There you go. I shall leave you with paper. Can you check? Here is a 12 volt state of charge, okay? See those? I will include these images in the video, by the way. You can pause it, by the way. I don't have to sit here all day. And then, where to go? There it is. This is the one for the higher voltages, okay? And it's slightly contradictory to what I explained, but these are basically lab chemistry. So I hope that was helpful, and that helps explain to you guys about the state of charge or the general voltage numbers that we use to generalize things. Thanks, guys. Remember, not everything is literal. Don't forget to like and subscribe. Join our Facebook, our Patreon. Leave your comments in the message description thingy below. Just comment if you want. You can tell me what you want to know. I'm done.